All right, so our last little bit for the review of pre-calc topics is going to be logarithms, and then we have a little bit with the graphing calculator. Okay, so 4a says log base 2 of x minus 1 minus log base 2 of 2x minus 1 equals 3. So if you remember, there is a rule that says like log base m of a minus log base m of b equals log base m of what? Close. A divided by b. So when you subtract logarithms, it's the same as division. It has to do with exponents. Remember, if you have exponents that you have x squared over x cubed, you subtract your exponents. That's the same idea for logarithms. So subtraction is related to division, addition is related to multiplication. Okay, so for this first one, we're going to have log base 2 of x minus 1 over 2x minus 1 equals 3. And then we try to switch forms. So hopefully you all remember how to switch from log form to exponential form. What I always did in Algebra 2 is I would take the base of the logarithm and I would kind of circle it. And I'd say 2 raised to the other side of the equation equals the portion that was left without the logarithm, right? So it's going to be 2 to the 3 equals x minus 1 over 2x minus 1. So that's how you switch from logarithmic form to exponential. Did you guys all remember that one? Yeah, hopefully you reviewed in pre-calc a little bit too. All right, so we get 8 equals x minus 1 over 2x minus 1. And we're going to multiply that denominator over. So we're going to have 8 times 2x minus 1 equals x minus 1. So 16x minus 8 equals x minus 1. Continue to solve, so subtract the x over. So we get 15x, add the 8 over, we get 7. So x equals 7 over 15. But with logarithms, you should always check. Okay, so if you go back and you check this into the original, you just want to make sure that you're not taking the log of a negative number. Are we? Yeah. We actually are, yeah. So if you check in, like this one, for instance, the x minus 1, when you plug in x is 7 over 15 and you subtract 1 from it, right, 7 over 15 minus 1 is a negative number. Okay, so this actually means that this answer is no solution. Don't you hate those? Oh, math class, where no solution is sometimes an answer. Do all that work for nothing. All right, so the next one. So I have natural log of e to the 5th. Now, if you remember, natural log is really just a fancy way of writing log base e. So we have log base e of e to the 5. And we have a rule that says we can bring exponents to the front. So we're really finding 5 of log base e of e. Well, what is log base e of e? 1, right? So this first part ends up just being 5. So we have 5 plus natural log of x minus 1 equals 7. And we subtract the 5 over, so we get 2. And then some people need to see the log base e. So if you need to see that, that's fine. You can write it. If you don't, that's fine. So what it's representing, natural log, is just a fancy way of writing log base e. I think we just got tired of putting subscripts in, so we made it up. All right, so we're going to switch. So we have a base of e, and we're going to do e raised to the 2 equals x minus 1. So we get e squared plus 1 is equal to x. So in the instructions, I say write answers in the exact form and then approximate to 3 decimal places. So I want both. So e squared plus 1 is the exact form. Oh, my calculator. Oh, there it goes. Thought it finally died. It's been yelling at me to change the batteries for like a month. But. All right, so x is approximately 8.389. So remember, AP Calc test, 3 decimals. So you can round or you can truncate. So meaning you can chop it off or you can round. Yes, Ron. Okay. Yeah. All right, so the next one. So it's already set up, so we have a log base of a number equals something else. So we can switch forms right away. So this is going to be 9 to the 1/2 equals x squared minus x plus 3. So 9 to the 1/2 is 3, right? Square root of 9. So we have 3 equals x squared minus x plus 3. So when we subtract 3 from both sides, we get 0 equals x squared minus x. So this is one we can solve by pulling out the GCF. So I have an x in common. I have x minus 1 left. So I get x equals 0, and I get x equals 1. So we just want to check both of those. So when we plug in 0, does it work? Yeah, it works, right? It doesn't give us a negative for the log, like the inside part of the log. We call that the argument, right? And then the 1, does it work? Yeah. Yeah, so both of them are good. So this one has 2 answers. All right, is it all coming back to you? Yeah, I don't know why when people see like logarithms, they get scared. Like, you know how to do logarithms. I've been doing them for 2 years. Do it. All right, so this one has a lot of like numbers. So we're going to use the rules that I was talking about with the log base b or log base m of a minus log base m of b. We're going to combine with division or multiplication or whatever we need to do. So in this case, I have log of 64 minus 32, so it's going to be 64 over 32. Right, so that becomes log of 2. But we also have that log of 5. So let's go ahead and take care of that as well. So I'm going to subtract it over here. Sorry, I'm kind of writing in a weird way. So we have log of x minus 2 equals log of 2 minus log of 5. So how does that combine? Log of, exactly, 2/5. So log of 2 over 5. So do you remember what we would do in this situation? Like when we have log of something equals log of something? Yeah, the logs can just kind of cancel out, right? It's really like you're doing 10 raised to each side, right? And then 10 raised to log base 10 goes away. But we don't actually write that step. It's basically saying log of a number equals log of another number. Those two numbers have to be the same thing, right? So we can just say x minus 2 equals 2/5. So we get x equals, it's really 2 and 2/5, but we don't really write like mixed numbers. So we're going to write it as an improper number. So if you have 2 and 2/5, you're going to have 10 over 5 plus 2 over 5. Yep, so you're going to get 12 over 5. So that would be the exact form. You could find the decimal approximation too if you wanted to, but that one's fine. Okay. Making sense? Okay, so let's try a few more. So how about if things are in exponential form? So these 4 are all in exponential form. All right, so I have 3 to the x minus 2 equals 8. So if we could get them to be the same base, we could do that. But 3 and 18 aren't going to be, did I say 8? 18. You can't get them to be the same base. Like they can't both be 3 raised to something, right? Okay, so this is one where we're going to either switch to logarithmic form or we take natural log of both sides or whatever. So one thing that we always did in Algebra 2 is we would switch forms. So we would do log base 3 of x, oops, not x minus 2, of 18 equals x minus 2. Because now you can see 3 raised to the other side equals 18. Okay. But the problem is a lot of people don't like switching to the other form. They find it to be difficult. So you don't have to. You can take any kind of logarithm, oops, sorry, any log of both sides. Okay. It doesn't matter what. So what I usually do is natural log, just because it's the easiest write. So I write natural log of 3 to the x minus 2 equals natural log of 18. So the whole reason logarithms were invented was to solve equations where the x was hanging off as an exponent, because it allows us to drop them. We can pull them to the front. So as long as you've taken the natural log of both sides, you can do that now. So now you can pull that x minus 2 to the front. So you get x minus 2 times natural log of 3 equals natural log of 18. And we divide, so we get natural log of 18 over natural log of 3 equals x minus 2. So your answer is going to be natural log of 18 over natural log of 3 plus 2. That would be like the exact form. So the approximation, we do natural log of 18 divided by natural log of 3, and we add 2, would be 4.631. So see, my calculator says 4.6309. The calculus test actually allows you to truncate. So even if you have 4.6309, you can just chop it off and say 4.630. I always round though. I don't know. It just seems more precise. And if you guys are building my bridges later, I want you to have like bridges that connect. Have I shown you that picture before? You remember that? I showed it last year. I'll have to show you a picture of a bridge that they built from one landmass, and they started another one from the other landmass, and they were supposed to meet in the middle, and the bridges like don't even connect. So they had to tear half of it down. Like, that's what rounding does for you guys. Don't round. All right, so the next one, so we have 64 and 16. So now can we get them to be the same base? Yeah, so you can make them both 2 or you can make them both 4. It doesn't matter. Okay, can't make them both 8. There's no, well, you could, but it'd be really weird. All right, so we're going to do 64, and we'll say that that is 2 raised to the, anybody know? 6. Right, so 2 to the 6th, and you're going to have 3x minus 1 equals 2 to the 4, and then we have 4x plus 5. Okay, so doing that, we get 2 to the, and we multiply our exponents. So 6 times 3x minus 1 is going to be 18x minus 6. And then 4 times 4x plus 5 is going to be 16x plus 20. So this is the same situation as we had when we had like log of a number equals log of a number. Okay, so we have 2 to something equals 2 to something else. Okay, those exponents have to be equal to each other. There's no way they could be, like you could have that equation without it. So we're going to say 18x minus 6 equals 16x plus 20. So basically it's like we're taking a log base 2 of both sides to get rid of the 2's. So subtract the 16x over, so you get 2x, add the 6, you get 26, so x equals 13. All right, so the next one, so I'm going to subtract the 3 over and get 12. I'm going to divide by the 8, so e to the 3x minus 7 equals 12 over 8, which represents divisible by 4. So I'm going to say 3 over 2. So we want to get rid of the e, so we do natural log, exactly. So natural log of e to the 3x minus 7 equals natural log of 3 over 2. And natural log and e cancel. So when you bring that 3x minus 7 to the front, natural log of e is 1. So you get 3x minus 7 equals natural log of 3 over 2. So your answer is going to be natural log of 3 over 2 plus 7 all over 3. Okay, and the reason I have you write it in this exact form is because that's how your multiple choice will be with logarithms. So the multiple choice answers are going to be in the exact form. They're not going to be decimal answers. So you need to know how to move things around and simplify. All right, so they might also have something like natural log of 3 minus natural log of 2 plus 7 all over 3, right? See how they could use the rules of logarithms and break it apart. So look for weird things like that. All right, so if we find this answer, did anybody find the decimal approximation? Yeah, I like that number. Even numbers 2, 4, 6, 8. All right, and then part H, these are the hard ones. Okay, this is when you have something raised to something with x, a number raised to something with x, right? They get a little bit hard. So you don't have to do like log base 5 or log base 7. It doesn't matter. Do any logarithm. So again, I'll do that natural log. So I'm going to do natural log of 7 to the x equals natural log of 5 to the 3x minus 1. And I'm going to pull those powers to the front. So I'm going to have x times natural log of 7 equals 3x minus 1 times natural log of 5. Yeah, you can divide like either natural log over. It doesn't matter which one. I'm going to distribute. So I'm going to have x times natural log of 7 equals 3x times natural log of 5 minus natural log of 5. These ones are weird. So I usually distribute. And since I'm solving for x, I get all of my x's on one side. Okay, so it doesn't matter which side. I would probably get them on the left side. So I'm going to have x natural log of 7 minus 3x, minus 3x natural log of 5 equals negative natural log of 5. Because now that I have them all on one side, what can I do? Yeah, pull out the GCF, right? The GCF is x. So just pull out just plain x. It doesn't have to be like 2x or 3x or whatever. It's always just going to be x. So I'm going to have x times natural log of 7 minus 3 natural log of 5 equals negative natural log of 5. So do you see where I'm going with this? So now I divide. So I have negative natural log of 5 all over natural log of 7 minus 3 natural log of 5. And we can leave it like that. That would be an exact answer. So let's find the approximation. So negative natural log of 5 divided by natural log of 7 minus 3 natural log of 5.
Could you simplify it more?
Yep, you can. I was just going to talk about that. So you get x is approximately 0.558. Now, the AP test, the thing that makes logarithms hard on the AP test is there's lots of different forms that the answer could be in. Okay, so if it's a calculator section, you're fine because you could just like find the decimal approximation of choices A through E. Actually, it might be A through D this year. They made the rule change, but I can't remember what year it's going to happen. I should probably know that. So you're going to have all these answer choices, and you can just find the decimal approximation for each one and then find which one matches up with your answer, right? But if it's on the non-calculator section, that's when it's really brutal for my students, because you have to figure out how to like move it around and figure it out. And I'll show you a classic one later in the year where my students are always like, oh my God, I didn't even know how they got that. Like, how did they go from this answer to this answer? All right, so what you could also do with this answer, the first thing I would probably take care of is the negative. I would divide by a negative on the top and the bottom. So I would do natural log of 5 all over, and I would do the 3 natural log of 5 minus natural log of 7. Do you see how I did that? I just divided by a negative 1 on the top and bottom. Okay, and then they would probably combine logarithms on the bottom. So this is kind of a complicated process because you have to bring the 3 up as a power first. So you have 5 to the 3. What's 5 to the 3? So you're going to have natural log of 5 over natural log of 125 minus natural log of 7. And then they combine using that division property. So you're going to have natural log of 5 all over natural log of 125 over 7. So that's probably as simplified as it would get. Weird, isn't it? Very different than the answer that we had too. That's the frustrating thing. It's like you know how to do all the math, you get an answer, and then you have to like get another form of the answer. That's the frustrating part. All right. So the next part. So do you guys want to try these ones first? I'll give you a second to try. All right, so Natalie just said when you add, you multiply, right? So this is going to be log base 2. And then you're going to have x minus 1 multiplied by x plus 3 equals 5. So you're going to have log base 2 of x squared. You're going to have plus 3x minus 1x, so plus 2x minus 3 equals 5, which allows you to switch forms. So you have 2 to the 5 equals x squared plus 2x minus 3. So 2 to the 5 is 32 equals x squared plus 2x minus 3. So when you subtract it over, what do you get? 35. Does it factor? Oh, you're so lucky. It took me a long time to find a good problem. I had to like think really hard about what would be a good one. So you're going to subtract 5 and add 7. So that way your outer and inner combine to be positive 2. So you get x equals 5 and x equals negative 7. So then you go back to the original and you say, can both of those work? So if you plug in negative 7, it's not going to work, right? Negative 7 minus 1 is a negative number, so you cross it out. Can you plug in 5? Yeah, 5 does work. Okay, so make sure you eliminate the ones that are bad. Did anybody get it all the way right? Oh, good. All right, so the next one, so we're going to multiply again. So we have log base 2 of 2 over 3 times 3 over 32 equals log base 4 of x. So this is difficult because they don't have the same base. You have log base 2 and you have log base 4. Okay, so this first one becomes log base 2 of the 3's reduce out, the 2 and the 32 reduce to 1 over 16 equals log base 4 of x. But we do know how to find log base 2 of 1 over 16. That is a number. We can do that. Does anybody get it? Did anybody get a number there? So let's think about it. If we have 2 raised to the 1/4, does it make 1 over 16? Yeah, that's the 4th root of 2. So you're close, very close. How do we get 1 over with exponents? A negative exponent, right? So let's use the 4 that he was talking about. It's negative 4, right? 2 to the negative 4 means 1 over 2 to the 4. That's 1 over 16. So that's what we want. So log base 2 of 1 over 16 is negative 4 equals log base 4 of x. So for solving, we're going to have 4 to the negative 4 equals x when we switch forms. So it's going to be 1 over 4 to the 4. Anybody know 4 to the 4? 256, is it 256? Yeah, it is, yeah. So 256, you're good, you don't have to think about it. All right, that's your answer. All right, so enough with logarithms. So let's use our graphing calculator. So it says solve the equations using a graph on a graphing calculator. Give answers as decimals rounded to decimal, as decimals rounded to 3 decimal places. All right, so we have 3x cubed minus x minus 4 equals 0. So we're going to want to find a 0 using our calculator. So that's going to involve left bound, right bound. Do you guys remember doing this before? Have you done this? Okay. So I'll do it up here so you guys can see. So go ahead and do this along with me. So get your calculators out. And we're going to graph. You can get this on your computer if you would like for free. There's a little download. It's called Wabbit, which is kind of weird. All right, so it's x. Oops, I always do that. Ah, dang it. I do that every time. I always hit x, but I need to type it, or I need to click it. So x to the 3. And then what was it? Minus?
X.
Okay. Minus x minus 4. Oops. Gosh, I'm terrible. So hopefully you guys are a lot faster than me. So minus x minus 4. All right, and then let's go ahead and everybody do Zoom 6. Zoom 6 puts your calculator on the standard 10 by 10 window. So it goes from, the x values go from -10 to +10. Y values go from -10 to +10. Okay, just make sure we all have the same thing. So did everybody get that? All right, so we want to find the zeros, and we're rounding things to 3 decimal places. So what we're trying to find is the place where it's crossing right here. A 0 is also another word for an x-intercept. So we're going to do second, trace, and we're going to find the 0. Okay, so option 2. Some of your calculators might say root. It's the same thing. So hit enter. So you can hit 2 and then hit enter. All right, so when it says left bound, you want on the left of what you're trying to find. So this is an increasing function, meaning it's moving up as it goes from left to right. Okay, so the left side of it is going to be below the axis. The right side is going to be above. So left bound is going to be right around here. Just make sure your y value is negative. Right bound is going to be above. Hit enter, and then I usually get to whichever one I thought was closer and hit enter. And it gives the 0. Did you guys get 1.796? No?
Yeah, I did.
Uh-oh. So what did you guys get then? Does it say 0? Did we type it in wrong? Did you tell me the wrong function? X cubed minus what?
3x.
Ah, you guys are telling me the wrong thing. No, because you told me the wrong thing in the first place. All right, so graph.
No, 3x cubed minus.
What is it now? Okay, 3x cubed.
Minus 4.
Okay, mine's covered up by this calculator. You gotta help me out, guys.
Drag the window.
3x cubed minus x minus 4. I can, but it messes it up, guys. So, all right, so second trace. So I want to find the 0. So left bound, right bound, yes. So I'll do that one. So 1.201. Did you get that? Yes, no? Okay, so 1.201. So you're not helping me out here. All right, so 1.201. All right, so easy enough? So can you do the same thing for part B? So you're going to put that in for y1. I'm just using my regular calculator. All right, so when you graph it, it should look something like, almost. Something like that. So we do second trace 0, left bound, right bound, guess. For this one, we get x equals 0.245. Okay, get that one? All right, now part C is a little bit different. So we have 2x squared minus 1 equals 3 to the x. So what I would do is I would put these in for x1 and y1. So you're going to put for, or sorry, not x1 and y1 and y2. So for y1, you're going to put the 2x squared minus 1. And for the other one, you're going to put 3 to the x. And you're going to hit graph. And we have a parabola. That was the first one, right? Intersecting with an exponential function. Now, it looks like maybe it intersects twice, but we're not sure, so we're going to adjust the window. So under window, we want it to go a little bit higher. So for our y max, instead of doing 10, let's try 20. So we'll see if it intersects again. So we have our parabola. Yep, and you can't really tell very well, can you?
No.
All right. Yeah, you can't really tell. So let's find the first intersection point, and then I'll show you how you can zoom out on that. So we're going to do second, trace, and we're not finding the 0 anymore. Now we're finding the intersect. So option 5. Okay, so first curve, notice how I'm tracing along the parabola. So when it says first curve, you're around the y1. And you want to go to where you think your intersection point is, so right there. And then second curve, notice how I'm tracing along the exponential graph. So go where you think the intersection point is and hit enter and guess, hit it again. So it tells us that our intersection point is negative 0.836. So negative 0.836. Okay, so that's the x value. Okay, but we're not really sure if there's another point. Okay, based on our graph, we can't really tell. So my favorite option for zoom, if I have a particular x value that I'm trying to find with an intersection point, is zoom box. So I don't know if you've ever used this, but it's cool. So you're gonna hit zoom, and it's option 1. And we want to just zoom in on that particular area where we think it's intersecting. So move your cursor up, and I'm gonna move it over a little bit. Okay, and then I'm going to hit enter once, and then I'm going to move over again, so it's creating the top of my box, and then I go down to create the bottom of the box, and once you have those two opposite corners done, hit enter again, and what it's going to do is it's going to zoom in on that rectangle that I just created. Okay, so hit enter, and now it zooms in just on that location. So the first thing drawn is the parabola, the second thing drawn is the exponential function. Do they intersect? No. So do you see they're not intersecting? Yes.
I think we just subtracted 3 to x.
Yeah, you could try to solve the equation and see if it worked. And then you're saying subtract it over and then find the 0. You could do that as well. It doesn't matter. A lot of times in AP Calc, you're going to have 2 graphs, though, because it's going to ask you one thing about one graph and one thing about another graph. So you might as well just put them together, as separate ones, I guess. All right. So that was the first one. So then the next thing. So we have 2 log of x plus 1 equals 4 cosine of x on 0 to 2 pi. So you should make sure that your calculator is in radian mode. Okay, so on your calculator, go to mode, and you want it to be in radian. So hit enter on the radian. And the calculator should always be in radian mode for AP Calc. So we have 2 log of x plus 1 and then equals 4 cosine of x. And this one gave us a certain interval. Okay, so it said on 0 to 2 pi. So that means that I'm going to go ahead and I'm going to change my window from 0 to 2 pi. So you're going to hit 2 and then the pi button, so second pi. And when you move down, it will change that to 6.28, whatever. Okay. And then the y mins and y maxes, it's going to be kind of tiny because 4 cosine of x, the highest point it goes to is 4, the lowest is negative 4. So let's go from negative 5 to 5. All right, we're going to hit graph. Okay, so the first thing it's graphing is the log function. The second thing it's graphing is the cosine one. Okay, so there's 2 intersection points on that interval. So you would find both of them. So you would do second trace. Has anybody found any of them yet? So how about I find the first one, you find the second one over there. So I'm going to trace here to get the first one. All right, so the first one's 1.381. Everybody get the second one? What'd you get? I'll go ahead and start it. It takes forever for the little cursor to move. You're feeling confident in your answers? No one's shouting it out? 5.117, yeah. Okay, so that one had 2 solutions. Make sense? Okay, and you can also do inequalities. This is kind of what we were talking about the other day with critical values. So what this is saying is when is it less than, when is it below the x-axis? So basically what you're going to do is you're going to find the x-intercepts, right? And you're going to find all of the places where it's below. So we're going to do x to the 4th minus 2x cubed plus 3x squared minus 2. I'll just put this on my normal calculator. So I'm going to hit graph. So when I graph it, it kind of looks like a little, there's something going on there, a little like squiggle or something down there, but there's basically only these 2 x-intercepts. You guys see them? So we're going to do second trace 0 again, and we're going to do left bound and right bound. Now when you do left bound, right bound, now the left is above and the right is below when we're on the left side of the graph. Do you guys understand that? So left side is above, right side's below. Back when I was in school, it didn't say left bound and right bound, it said lower bound and upper bound on the calculator, which was really frustrating because sometimes the lower bound, the left bound was above, and the right bound was below. So the upper bound would be below, kind of strange. All right, so for this one we get negative 0.650, well no, negative, we'll round up. So negative 0.651. And this other one, second trace 0. Left bound is now below, right bound is now above. Guess you get 1. So it's saying when is it below the x-axis? It's below the x-axis on the interval. Well, actually, don't do a bracket, do a parenthesis. Why a parenthesis? Right, it doesn't say less than or equal to, right? So it's on the interval negative 0.651 to 1. All right, and then same thing for the last one. I'll do it up here. Just make sure that when you're doing this last one, you put parentheses around the numerator and parentheses around the denominator, unless you have, I call it fancy type, unless it's actually making a numerator and a denominator for you, so you can clearly see the 2. Okay, so you're going to have x squared plus 3x minus 2. So that was all in the numerator, so I put it all in one big parenthesis, divided by parenthesis x plus 4. So a lot of people will forget the parenthesis around the denominator, and it messes it all up. So now we're saying greater than or equal to 0, and we're saying on 0 to 10. So when we do our window, let's just make sure that we're going from 0 to 10. Okay, and it looks like only one place, right? So we're going to do a second trace. It's not quite at 0. So we're going to do left bound, right bound. Left bound, right bound, yes. All right, so it's at 0.562. Now what would I write? So if it's on the interval 0 to 10 and I say greater than or equal to 0, do I do 0.562 to infinity? No, right? I have to stop with 10. Can I include 10 on this one though? Yeah, I can actually include 10. So I'm going to say 0.562. Well, actually, I can't include 10 because it wasn't included in the original, right? So it said 0 to 10 parentheses, so I guess I can't. But if it said 0 to 10 with both in brackets, then I would actually include the 10. Can I include the 0.562? Yeah, should this be a parenthesis or bracket? Yeah, it should actually be a bracket because it says greater than or equal to 0. That's where it was equal to 0. So it should be bracket 0.562 to 10. Okay, does all of that make sense? Can we skip those last two? You feel good about these? I don't have to do the last two. All right. All right. Oops.